Now, compared to the last video, we're talking about dummies in a three-variable regression. And here we drop the English language proficiency, and the coefficient for large schools dramatically change from adding 5 points to subtracting 5 points, holding student-teacher ratio fixed. All right, let's see what that means. All right, with a dummy variable. I cannot do easily with a three-dimensional graph, but I certainly can do a two-dimensional graph to illustration the dummy effect, the dummy here. So we have a two-variable regression. We see that the student-teacher ratio now has the impact on the test score by -2. The large school make it even worse. All right. So the regression line on this graph we see is two parallel lines. All right. So basically, we see small schools, the intercept is 695, whereas the large school intercept is 689. That's more than 5 points difference. So basically, we see the intercept is the line that hits the vertical axis. All right. Now, the intercept here, we can see the constant term on the regression says 694. That is for small schools. The large schools intercept is the constant terms plus what's on the large school coefficients. So the large school coefficients tell us the difference between small school and large schools. And also what it does is that that difference persists on all the way each level. So we have parallel lines, all right? So in other words, when we fix the student-teacher ratio at any level, 16, 18, 20, 22, whatever it is, then the large school and small school will have difference in their average test scores. So that's the purpose of in the dummies in here. So it gives us that along this line, what's the gap between these two schools on average.